I want to preface this video by pointing out that what we're going to be looking at here is going to be the cornerstone from the moment you see this video until the time you take your very last chemical class and do the very last bit of chemistry you will in your life. And probably past that too with other coursework that you may be taking. But for chemistry majors especially, this is going to be the cornerstone of your life. For other people who are here to use chemistry, even if just in this course, this is going to be the cornerstone of the rest of your semester and probably some coming semesters. So, what does that mean? Polish the heck out of this approach because you're going to use it a lot and it's going to be a really critical skill to get the right answers for everything else you're going to do. Now, you see here we have a balanced chemical equation. And down below we have the word problem that's associated with it. So you can see here that we've balanced it. So we have 2 aluminums and we have 2 aluminums. We have 6 hydrogens, 6 hydrogens, 6 chlorines, and 6 chlorines. So this is a balanced chemical equation. Now if we take 26.98 grams of aluminum and we react them with excess HCl, here excess is telling us that we have more HCl than we need. How many grams of HCl will be consumed? Well, here's the conceptual underpinning for how we're going to solve this problem. First, we're going to write down the fact that we have 26.98 grams of aluminum. That's the main piece of information we have here. But we have a few extra pieces of information hiding behind the scenes as well. We know that it's grams of aluminum, which means that we can use the molar mass of aluminum to tell us how many moles of aluminum we have. Almost any time we start out with mass, we need to get into moles. Also, now that we have a balanced chemical equation, our stoichiometric coefficients are going to tell us the ratio that we have between aluminum and anything else that's in this reaction. Well, the ratio of aluminum that we have to the HCl we're going to consume, for every 2 moles of aluminum we use, we'll be using 2 moles of HCl. So we'll use the stoichiometric coefficients to get us to moles of HCl. The very last step we're going to do is get to the unit we need to be in, which was grams of HCl. And to go from moles to grams, we're going to use the molar mass of HCl. That's our basic approach that we're going to use here. Now, we have 2 choices. There's the one that I like most and then the one that I like a little less. I'll show the one I like most first. What I like to do is chain them together using an organization method we call the fence post because it looks like a fence post. We're going to chain together all of these conversion factors, these fractions, in a single math problem. So we only have to grab the calculator once, we only have to round once, and so we can use the units to really help guide our eye and make sure we're following our path correctly. Now for that, first thing we're going to need is to get our conversion factors figured out. Now we have our molar mass of aluminum, which we can just get from the periodic table, and that will be 26.98 grams per mole. However, for HCl, what we have to do is take the mass of hydrogen, the mass of chlorine, we add them together. Remember when we add, we line them up at the decimal point, we chop off after the shortest place, so it'd be 36.46 grams per mole. It'd be even better if I had done that drop notation where I keep them added together, and that would be written as 0.458, with the 8 being a lower version number, so that we know that it's not a significant place, but it prevents early rounding. Either way, we'll be okay for this example that I'm showing. So what we'd do is we'd set it up, we'd have our grams of aluminum, we have to convert into moles. So I'll put my molar mass of aluminum on the bottom, put my moles on top, my grams cross-cancel, and aluminums cross-cancel, leave me in moles. Next up, I'm going to convert from moles of aluminum into moles of HCl. I use my stoichiometry for that. I have 2 moles of aluminum using 6 moles of HCl. And you can see that right here. Moles have cross-cancelled, aluminum cross-cancelled. I am now in moles HCl. The last piece of the problem is going to be converting to grams of hydrochloric acid by using the molar mass of hydrochloric acid, which we figured out here. So it'll be moles in the bottom to cross-cancel, grams on the top, moles cross-cancel, HCl cross-cancels. You can see our final answer is going to be in grams of HCl. So we're going to multiply our numbers across, we're going to divide across, and that's going to give us our final answer. Now if you want to do it piecemeal, what you could do instead is handle each of those as a separate piece. So I take my grams of aluminum times my molar mass, and I end up with 1 mole of aluminum present. Now hopefully you look at this and you say, well, wait a minute, Davies. Those don't look like correct sig figs. And you're right. We have 4 sig figs here. I have 4 sig figs here. 1 mole is an exact number, which has infinite sig figs. And so we're going to have 4 sig figs on our final answer. So really we're going to have 1.000 moles of aluminum present if we're going to keep track of our sig figs. Let me just clean that up. Okay. Now we'll do our next piece of the problem. 1 mole of aluminum with 4 sig figs times the 6 moles of HCl divided by 2 moles aluminum. That's just doing the conversion factor. We said we have 2 aluminum to 6 HCl. Moles aluminum cross cancel. I end up moles HCl used. Again, will be at 4 sig figs because these are both exact values. So 3.000 moles of HCl are used. Then I'll use my molar mass to convert from my 3 moles of HCl into grams. And that'll give me 109.38 grams of HCl. We're at 4 sig figs, so we'll chop it off right there. So my final answer would be 109.4 grams of HCl would be consumed. That's how we'll put together these pieces of one of these problems.